So in this video we are going to discuss about the conservation of the linear momentum, or you can write down the law of conservation of momentum. So law of conservation of momentum. That we are going to prove. So what is the law of conservation of momentum? So according to the law of conservation of linear momentum, the total momentum of a system, the total momentum of a system remains conserved in the absence of an external force. So also you can say that the momentum before collision is equal to the momentum after collision. So you will go through the mathematical formulation. Now we'll take two balls here. This is one ball A, this one is ball A, and this one is ball B. So they are going in the straight line in this direction. They are going. So the mass of A is m1, mass of B is m2. So velocity of ball A is u1, velocity of B is u2. Now in this point they collide with each other here. So A ball and B ball. So A will apply a force on B in this direction, that you can write a BA, and B will apply a force in this direction, then we will apply FAB. Okay, so after the collision will take place, the velocity of the A and B will change and they will go in the same direction. So this is again mass m1, and this one is mass will not change, the velocity will change. So velocity will become v1 for A and velocity will become v2 for B. So this is A. So that this thing will happen. Now there are two things happened here, you can find out. So this is before collision and this one is after collision. So this one, right, before collision, and this one is after collision. Now this is the collision, and the time taken for the collision is t. A small time will be taken at the time of collision, that is t. Now what is the momentum before collision? So momentum before collision is will be how much? m1 u1 plus m2 u2, and momentum after collision will be m1 v1 plus m2 v2. So this is the thing. Now first we have to find out the force FAB, and then you have to find out force FBA. So the FAB is the force applying on B by FBA is the force applying on B by force A. So we can find out the rate of change of momentum of the B, and also we find out the rate of change of momentum for A. Okay, so for the first A ball, what is the rate of change of momentum? So first ball, the velocity has changed from u1 to v1. The rate of change of momentum that is also called the force. Okay, so force applied on A is AB. So if AB will be how much? M1 V1 minus M1 U1, rate of change of momentum is by T, and rate of change of momentum right for A, and rate of change of momentum for B, VFBA will be M2 V2 minus M2 U2 by T. So also here you can see, according to Newton's third law, FAB is equal to minus FBA. We put this value here, these two things, so you get M1 V1 minus M1 U1 by delta T is equal to minus M2 V2 minus M2 U2 by T. So TT will get cancelled. Then you can write M1 V1 minus M1 U1 is equal to minus M2 V2 plus M2 U2. So now if we bring this one is this side, so we'll get, or this one in that side, so we'll get we'll take this one in this side, so we can write M1 U1 plus M2 U2 is equal to, and you bring this one in this side, so M1 V1 plus M2 V2, so which is nothing but momentum before collision is equal to the momentum after collision. Okay, so this is the conservation of linear momentum. So when write momentum before is equal to so this is known as the conservation of the linear momentum. Okay, so thank you very much.